Alright, so we've got one more electromagnetics question. We're told to draw a diagram demonstrating how a railgun uses magnetic fields to accelerate an object. We're told to show the rails and the wire, show the magnetic fields, and show the force on the wire. Alright, so a railgun, we've essentially got two rails, which we might draw as little rectangles like this, rectangular prisms. So we have one here, and we have one sort of parallel over here. Obviously this can have various different design structures, but this is one possible one. It has a current running through it, and it has a wire connecting it. So there'll be a wire connecting it, some loosely sitting object in here, which closes the circuit. There will be a current running in some direction through this object. So in this way, up here, through the connector, and out. So the connector essentially closes the circuit between the two rails. So this is rail 1, this is rail 2, and this is the wire that connects those two rails, that closes that electrical circuit. So show the rails and the wire, this is done. Show the magnetic fields. Alright, well let's imagine the wire is at some place much later on, because this is going to be easier to demonstrate. So the wire has now moved over here, so we have current coming all the way up here, going through the wire, going all the way back down. As the current travels along each of the rails, it is going to generate a magnetic field around that rail. Now you can work out the orientation, the rotation, using a variant of the right-hand rule. So you point your thumb in the direction of the current, then if using your right hand, point your thumb in the direction of the current, then the direction in which your fingers wrap on your right hand is the direction of the magnetic field, or the orientation of the magnetic field. So the current goes up this way, then back this way. So if we point our finger in the direction of the first one, we find that this magnetic field will rotate around this way. If we go the other one, we'll find it will rotate the other way. So its orientation will be reversed. So these are the magnetic fields through the two rails. Now we need to show the force on the wire. Well, this little projectile, this object, which we're calling the wire, essentially sits between two magnetic fields, right? It has a length, it has a current between it, and so what's going to happen is it's going to be accelerated by both of the fields. Now the fields, due to their opposite orientations, are both going to accelerate the object. And you can work this out if you think about the formulas for calculating the force due to a magnetic field. So you know force is equal to the length of the object times the current times the magnetic field times sine of the angle. In this case that's not a problem. So on one side the magnetic force will be pushing up through the wire. On the other side it will also be pushing up through the wire. So you have the magnetic field vectors on both sides of the wire going in the same direction. Now to work out the direction of the force, the current goes across through the wire. We point our index finger in the direction of the current. We point our middle finger in the direction of the magnetic field, which is up. And so our thumb points in the direction of the force. The force is going to be this way. So the force due to both of the magnetic fields is going to be, in this case, forwards, right? This is, you're aiming the railgun at something that's over here, and it's going to accelerate the object because of those magnetic fields. This is one of many variants of this type of object. So there are many weapons and many types of autonomous system that rely on principles involving things like magnetics. Not all guns using magnetics will work exactly like this. But this is a sort of basic model for something that we often refer to as a railgun. It doesn't mean every railgun works exactly like this. There's bound to be slight variations on this, because there always are in terms of weaponry and in terms of any implementable device that relies on this principle, but this is one way that such a thing operates.